Hello everyone. Welcome to today's session, Lambda functions in Python. Today we'll learn what are Lambda functions. So as we have already seen what are functions, how functions help you write reusable logic of code or reusable block of code that you can use multiple times in somewhere else in your program or in some other uh, programs whenever you want to reuse. So similarly, Lambda function is an anonymous one-liner function that helps you to quickly write a logic and execute a particular logic and do not need do not ask you to define that logic. So there is no def keyword required to declare the lambda function. Okay, so in this session, I will define what is a lambda function and explain when to use it, and we'll write beginner, intermediate, and advanced lambda expressions, and will leverage map, filter, and reduce for functional data workflows, and will integrate lambda into real world tasks such as sorting, pandas, apply, or ETL kind of things. We'll see how you can use this. So we'll thought process on it. So what are the common pitfalls that you can avoid, and what are the common performance tips that you can avoid with lambda functions? Okay, so let's first see what is lambda function. So lambda is a keyword. So it's a keyword that defines that you're writing an anonymous function. It's a tiny anonymous function. So the syntax of is lambda keyword with parameters and a colon and an expression. Expression is a logic. For example, you're calculating a plus b or a into b. Those kind of expressions come here. Okay. So the characteristics of lambda function is there is no def keyword. There is no name of the function. So it must fit one expression. There is no multi-line in the lambda function. Okay. So every lambda function returns the value of that expression automatically. As soon as you write the expression here, it returns the value. So you can think of lambda as a quick function that you write whenever you need to build a functional logic. Okay. So in so lambda function is an anonymous function which we have already discussed. It uses single expression callable defined with lambda. So inside lambda we use single expression, and it often used as an inline callback handed to map, filter, and reduce. Okay, so we always uh, tend to write this lambda function inside map, filter, and reduce, but there is no need that you should always use map, filter, and reduce. If you use lambda function with combination of map, filter, and reduce, its performance will be the best. But if we can also use generally without using map, filter, and reduce. So what does map do? It transforms your data. What does filter do? It finds out true or false and just keeps the true values and excludes the false values. And what does reduce do? It combines all of your data into one single aggregated value. Okay. So here is the sample lambda function. So how do you write lambda function? You define the keyword lambda and give the expression x comma y, the values that you take as an input from the user, and you write the logic x plus y. That's a simple. This is the lambda function. Now I'm putting all these lambda function into a variable called add. So now this add will become my function callable. So it will become my callable. So now I'll pass these values 3 comma 5 to lambda. So now it will take the value, calculate x plus y, and give me the result. So this is how it works. And if you want to calculate square of numbers or a square of a number, so you just pass the value here. So I have declared a variable square and wrote the lambda function and just give a variable name n, and then I wrote my logic here. So I'm passing the number 7 and it will calculate and give me the result 49. So same way, how do you write these functions in traditional way. So that would be you have to define the EF keyword, write your function name, declare the arguments that it will take, and then return the value. So whoever calls this function, the function will return the value. So this is how traditionally we write the function. So in these types of function, you can write complex logic, multi-line complex logic. But in Lambda function, there is no, it does not take multi-line complex logic because it's not defined to write complex logics. It's Lambda functions is useful when you want to write a simple logic that you want to calculate on the fly. Okay. So you can make a note of this so that it will be helpful for you. So here's a quick warm up. So let's say I want to convert Celsius to Fahrenheit using Lambda function. So it's my quick uh, logic that I want to build. So I can build using function, def keyword, write all those function inside that I can write the logic. But let's say I want to write it using Lambda function. So first I need to know what is the calculation to convert a Celsius to Fahrenheit. The calculation is take any Celsius number, multiply it with 1.8 and add it with 32. So that would convert our Celsius to Fahrenheit. So similarly, I wrote my Lambda function. I'm taking the value input from the user and I'm multiplying my value into 1.8, then added 32. So that would calculate my Celsius 30 to Fahrenheit 86. So that's how it will calculate. Or similarly, we can use Lambda function along with map, filter, and reduce uh, uh, you know iterators. So these are some of the helper functions. So these are functional helpers. This let you run Lambda across data without explicit loops. Okay. So if you want to run Lambda function on multiple data without defining for loops, explicit loops, so you can use map, filter, and reduce. So the order is map comes first, then filter, then reduce. When you're trying to solve a complex logic. So what does it do? Map applies the function to every element. So for example, I have 1, 2, 3, 4. So what does map do? It applies the Lambda logic to every element in Python uh, in the data type that you have written. So map in Python 3 is lazy. So map is a lazy operation. It returns an iterator that produces the converted values on demand. Okay. So let's see a sample. Okay, numbers is equal to 1 2 3 4 for I in range length of numbers print number. So this is the traditional way we write using for loops. So if I execute it, I will be able to find out the squares of the numbers. Okay, so similarly using list comprehension. So we already seen what are list comprehensions. So we write the logic and for loop. In the for loop, we'll say for x in number. So in these numbers, it will automatically loop and give you the list of squares. Okay. So now let's say I want to calculate a list of Celsius numbers and convert it into Fahrenheit. So I can use for loop and convert, but I want to use Lambda function. So Lambda function just works on one number. So it can calculate one number at a time. So what if I want to calculate my Lambda logic across all these lists at once? So for that, I need to use map function. So map function, as we have seen, what is the definition of map function? Applies the function to every element. So first it will apply the function to every element. Also, it's a functional helpers. It lets you run lambdas across data without explicit loops. So that means this one lambda logic will be applied to number one, number two, number three, number four to find the squares of the number. So it's iterable also. This is the syntax. Map with a function. So we write lambda function. Here we write what is iterable. So we'll pass it list, tuple, anything. Okay. So uh, inside my map function, I wrote the logic to calculate Celsius to Fahrenheit. So this is another way of writing Celsius to Fahrenheit logic, and I'm passing my Celsius value. So this is my map. Uh, Inside map, this is function, this is iterable. So once I run this, you can see I see the object. So it did not execute uh, at once. Like when I when I called the map object, it did not execute all these values completely. So it just stored the function and the reference to these values in this object. It did not calculate my logic yet. So when does it calculate? So let's see some of the characteristics of map. So what does map returns? When you call map function, it returns an object. So here it returned an object, and internally it stores two things. What is the first thing? A reference to the lambda function. So where is my lambda function? Here. It will map function will store a reference to the lambda function in this object, and a pointer to the original iterable. So that is our original iterable is Celsius values. So it will store a pointer to this. So these two things are stored in this object. Now it's not yet it did not execute the logic yet. So when will it execute? It will execute any operation that pulls that iterator triggers. Okay, any operation that pulls from the iterator triggers the lambda for each element. So if you say list of map, list tuple of map, sum of map, only then it will execute. So now it's just sitting as an object with a reference to this function and reference to this iterable. And when you call with a list of Fahrenheit item. So what is my Fahrenheit item? My map function. So now I'm calling my map function with a list. So that is an action. So then it will start executing at once. So it will take these iterable and lambda function and quickly calculate for each Celsius what is the Fahrenheit, for 0, for 10, for 23.5, for 37, for 100. Okay. Now same way, if I if I want to write at once, this is how it will be. Tuple of, so it will convert this into tuple also. It will convert this into list also. So once you call that map function with list or tuple, then only it will execute. Until then, it will sit as an object with a reference point. Same way, you can call some function also to add all those Fahrenheits. So why this map function is lazy? So what's the use of this laziness? So first is memory friendly. So let's say now I have given 4 to 5 list of Celsiuses. Let's say you have lots of them, like gigabytes. So how would it be helpful? So this will be helpful because it did not execute it. So memory wise, it did not store the data in its memory. It just stored the pointer. Okay, here is my data, here is my function. So it's just stored the pointers. Now when we call the action, then only it will execute. So that way we are saving some memory. So it's memory friendly. Also, it's composability. So you can chain iterators. For example, you can chain map, filter, map. So in multiple chains, you can run. So that will, help you. The data will flow through the pipeline in single pass. Okay. So in just single pass, single range of values, 0 to 10, you are passing at one single time. It executes all at once by looping through multiple functions and just gives you the result. So here, example, you can see I have an inner map. So in the inner map, I have a lambda function. What I'm saying, square of numbers of these values between 0 to 10. Of course, it will calculate this inner map function. So I will get square of all the numbers. So the square of all the numbers will be 1, 2. 2 square will be 4, 3 square will be 9, and 4 square will be 16, 207. So these will be calculated, and these numbers will be passed to the filter. So what filter will check? Even or not. So it will check even or not. So only even numbers it it will pick, and remaining it will put it in false condition. So since it's false, the filter condition will not pick those numbers. So all the true values, all the events will be passed to another lambda function that is there in the map function. So now this lambda function, what we are saying is all these events that we pick finally add +1 to it. So that's how it passes. You know, in just single pass, we are able to do all of these. Okay. So this is how the program gets executed. You can read these details to understand it better. Okay. So here the image that shows first innermost is executed, then middle filter, then outermost. Okay. So I have noted down two exercises. So you have to build a program to calculate the reverse Fahrenheit to Celsius. Just find out what is the formula to convert Fahrenheit to Celsius, and write a lambda function to convert any Fahrenheit value to Celsius. Same way, now try to convert all these Celsius, uh, calculate the Celsius of given Fahrenheit. Okay, so you can use map and lambda function. Combination of those two can write this program. So next we have filter. This is also a functional helper function. So that can be used along with lambda function. So how I can use it? So this is the example. So list and filter. Inside filter, I can write my lambda function, and I can give the iterable. So inside the filter, I have my lambda function, I have the iterable. So filter is to find out even or odd, I'm saying, and iterate all these values at once and get only events. Then even the filter function is also lazy. So only if I call list tuple, then only it will execute. Until then, this will remain as an object. So it will store the reference to this lambda function as well as the original numbers. So only if you call this with a list or a tuple, then only it will execute the actual logic. So this also, as we seen, how it helps in map function. So it is memory optimized, and also it helps. It's composable. You can chain, map, filter, and reduce. So there are two advantages of having a lazy operation. You can chain those operations with map, filter, and reduce, so that uh, without you waiting for intermediate results, you can pass the intermediate results to another map function and another filter, so that you can calculate all the result with one single pass. So once you pass all these values, it iterates through map filter, and then finally gives you the proper output. So let's say I have this value, of 10 lakhs, 1 million. So from 1 million values, I'm saying filter, I'm applying a filter. I'm just saying keep only even numbers. So you notice how many times it has to go through. So it goes through all these values at once. And finally, whatever the value remains, it adds +1 to it. And then on top of that, I'm saying do a summation. So you can see I'm able to chain between uh, map, filter, and reduce. So this sum will work as a reduce. So I'm aggregating those values into one result. So I'll get, this is the number I get here. Okay. So this was about filter. Now let's see reduce. So even reduce also has function and iterable. So to use reduce, you need to import function tools. From function tool, import reduce. So this is how you can use. So what does reduce do is it combines everything into one value. It just gets one value at the end. So now you can see here I have a list of numbers. So I need to multiply all these numbers. So what does reduce do is first it takes one number and it takes second number. So it multiplies both of them and gets the value 2. Then second, it takes this value 2 and multiplies with next value, that is 3. Now it gets 3 twos are 6. Now it takes 6, value 6, and multiplies it with 4 and gets the final value 24. Okay, so here we'll get the final value as 24. So now all these values, so the what was the first value? The first value was 1. So all these values that we are getting, so 1 and 2, 6, and 24. So all these values are called accumulators. So these are intermediate results. So what does reduce do is it uses intermediate results to calculate the final result. Okay, so here I have put some notes. You can go through and read it here. So how does a reduce work with lambda function to just get one result set at the end? Okay, so similarly, let's say if you want to see intermediate results, how can you see the intermediate results? You can use accumulate. So from iter tools, instead of reduce, you can say import accumulate. So when you say that, instead of just one result, you can see 1, 2, 6, 24. Similar to what we have seen, our accumulate 1, 2, 6, 24. So these are accumulators. Using these accumulators, reduce calculates the final result set. Okay. So if you do not use accumulator like we have used it here from iter tools import and accumulate function here, list of accumulate, if you use reduce directly, what it does is it gives you 24. And notice reduce is not a lazy function. If you use reduce directly, it will give you the final result set. You don't need to use list or tuple around it. Okay, so similarly, you can do a running sum of accumulators like 1, 2, 3, 4. So that will give you accumulators that will show you intermediate results. Okay, so here is a real world use case. For example, you have uh, a transaction list of transactions. What we are saying, just get me high value spends, those who spend greater than 10,000, and separately I'm calculating GST for each of these transactions. So if I run it, I can get high value spends 2 and GST's amount added to each of these transactions, that is 18%, is uh, this is the converted final list. So similarly, you can calculate, take this list of prices and use map and lambda function to add 12% tax to each of these numbers. So you can write a sample program that will improve your hands-on on lambda function. Now let's see some of the advanced concepts of lambda function. So let's say I have a list of dictionaries. So I need to find out top paid employee from this list of dictionaries. So what is it that I need to find out first? I need to sort my data in such a way that only the top paid employees come first. So for that, we can use sorted. So sorted is uh, you can use lambda with sorted, and we can get the result. Okay. So sorted of employees. So what we are saying, sorted of employees on key. So what is that key? Key is the salary. So we want to sort the employees data based on salary and reverse equal to two in the descending order. So that's a simple keyword. It sorts the entire dictionary, list of dictionary. Now what we get is, now you notice our dictionary first Asha salary now 9,000 was at the first place. Now after sorting we got Ben at the first place because he has the highest salary. Now just we want to pick the name from our dictionary, list of dictionary. So for that first I need to grab the 0th position. So this is what I'm saying. Top of 0. When I say top of 0, I'm just picking the first dictionary. And from that first dictionary, and if I say name, so I'm just picking the name of that uh, person who has the highest salary. So finally, I get top earner as Ben. So similarly, I can use pandas to use apply helper function along with lambda to calculate gross and net. So I already have a sample data of gross amounts. Okay, so this is a gross amounts. Now I want to calculate net amounts for that. So what is it that I can do? So df of gross dot apply. In the apply function, I can say lambda gross into. So whatever the gross I'm saying, this G is the gross into 0.7. So we have to reduce 0.7 from the gross amount. So that way we'll get net. So it will calculate the gross and net number. So we'll see how to work with pandas in another lesson. So that's a different external library. So here just an sample how using pandas data frame we can use lambda functions along with pandas data frame. So this is an example for that. Okay. So let me ask you three questions so you can solve it. So that way you'll be able to check your understanding whatever you have learned with lambda functions is correct or not. So what restriction does a lambda have compared to normal function? So you can answer that and fill in the blanks to keep only string longer than 5 characters. So write a fill this logic here to get uh, um, only words which are longer than 5 characters. Okay, which helper function, map, filter, or reduced would you pick to compute an average? Why? So if you have answered this correctly, then great, you have understood it very well. So if you have not answered this correctly, then you can revisit this topic and go through this notebook again, once again. Okay. So to answer quickly, lambda function does not have any definition keyword. So it's an anonymous function. It just takes one liner expression to calculate. It can be used along with map, filter, and reduce to chain these tasks into with one single pass. I can calculate complex logic. Okay, so there are no statements, no assignments, no return, no loops, no try except log. Okay. A regular definition function can hold an unlimited series of statements and control flow blocks. Everything else you notice, implicit return, no docstring, tricky debugging, is a side effect of that single expression rule. Okay. So lambda is single expression function. So how you can write a function to get words that are greater than 5 characters. So this is how you can write lambda x, length of x greater than 5. So this is how you will get a, a result of those words which are greater than 5 characters. Okay. So that's it for today. So if you want to do more reading, you can go through the official Python documentation of uh, Lambda functions to understand more, or if you want to dig further into it. So that's it for today. We'll meet next time. Until then, thank you. Bye bye.